All right, why don't we go ahead and get started. Again, my name is Eric Gustafson, and on behalf of Structures.Aero, also known as SDA, or Structural Design and Analysis, I'm going to be talking to you today about Femap version 11.3 that's just come out. We'll talk about some things that are new about it and differences from old versions. So I'll go ahead and get started here. All right, so with 11.3, I should note that Siemens tends to release a new version of Femap about once a year. Here we have that timeline going back to version 10 in 2008. The goal of this release is to introduce some new functionality that they've added, just to bring on new features and also address some customer input for requested features. So we have a bunch to talk about, so I'll be sure to make these slides available afterwards so you guys can review. 11.3, how do I get it? Well, the all-important link is in the bottom right there. For our current customers, they can just head to that site with their WebKey account and pull down a copy of 11.3. Now, it's a major release, so you need to update your dongle codes if you're licensed through the node-locked version, or if you have a network license and a server, you'll need to pull down a new license. If you have any questions about that, reach out to us. We even have a license FAQ page with the link right there. I've got the agenda laid out here. Follows the typical simulation process, so we'll address kind of every avenue of Femap and with regards to the simulation. First topic is preprocessing, so let's dig right in here. Draw erase. Okay, so new for version 11, the draw erase toolbar provides an easy way to control entities that are drawn on the screen and those that are erased. So with this, you can select things like elements, properties, materials, geometry elements like solids, curves, points, etc. This allows for more versatile viewing control in your graphics window. It also makes it great for peering into a model by blanking out any obstructing entities from view. There's a new toolbar you can see right there that gets put right up top. And that can be used to actively drop things from view on the fly. So I got a little demonstration of that, and I'm going to click through it. I hope that the animation comes through over the web just fine for you guys. But just going to get into it here. So I've selected elements. That went kind of fast for me, so this will cycle again so you can get a sense of that. But next it's going to erase. No, it's going by elements actually. So here I am selecting some elements to take out from view, just using the menu and the selector erase option here. So I'm just dropping things off pretty much on the fly, and it's really quick and easy to be able to dig into a model this way. So first I went elements, materials, properties, that is, and then materials, and you can use any one of those to kind of dig through at whatever pace you'd like. So a couple notes with this. Entities must already be visible. So if you got something hidden from view using layers or groups, then you won't be able to adjust their visibility with the draw erase menu. And then if you think of it like a hierarchy, when you eliminate a solid, it's also going to eliminate the underlying surfaces, curves, points, etc. Ditto for curves. If you eliminate a curve, it's going to take off the points from view as well. So this is really nifty and a good way to start on the changes to 11.3 here. Defaults for model rotation are the same as before, but you'll notice a few more options in 11.3 for what to rotate about. You may also notice that roll through option, and we'll get to that in a moment. But I do now want to bring up two options not offered here. They're instead offered under the File Preferences dialog, and I've got some slides covering those. Those are really interesting. I got a slide later on roll through. We'll get into that as well. Okay, jumping to rotate about cursor. This is the first thing I wanted to show. You may have probably found yourself in situations in the past where you start to rotate the model in the graphics window there in Femap, and whatever is in front of you just inadvertently swings out of view, and that can be frustrating, I know. This could be caused by having the rotation point or view center just too far away from where you're working. 11.3 introduces two options under preferences on the bottom left there under that group called mouse interface, one of which is dynamic rotate about cursor location. The other is dynamic zoom about cursor location. So let's first talk about rotate around cursor. With that enabled, the pivot point will be automatically selected based on where you clicked on the model. So I've got a little demonstration here that will show that the effect of that, kind of like a before and after. So in 11.2 up above, if you started to rotate after clicking on the left side of this tube, it might move you around a bit. And if you're trying to focus on the left side there, you'd find yourself having to reorient and waste a little bit of time trying to get that back into view. But with dynamic rotate about cursor location, you can select, and you'll see at that point you clicked on or pivoting about stays in view. So that's really convenient and reduces frustrations greatly when you're working with the graphics window there. Zoom around cursor is the next one. This one's pretty straightforward. The window will zoom when you say scroll with your mouse. You will be zooming towards the cursor location. So this is a quick demonstration of that. In the upper right, you can see I have the mouse cursor in the upper right in both, and it's zooming not about the cursor before, but just towards the center there, and you kind of see how it's zeroing in on the cursor location with this behavior, with this option enabled in 11.3. So those are two very convenient features new for 11.3. Another one that you saw earlier is this roll through. So this is like a mode that you can enter, and with that off, you will experience the behavior that you always had in Femap, which is you twist and rotate the model and you zoom into it, but you never really are traversing. And I've got some slides to explain what I mean by that coming up, but they will essentially explain how you're moving in roll-through mode. You're moving the viewer's eye a certain depth into the screen, and everything behind that is clipped. So it's removed from view, and you can see a quick little shot here of this, I think this satellite structure where the roll-through has clipped the structure so you can see inside it and all the internal elements. So a quick diagram explaining this. I've got kind of three situations up front. Imagine a clipping plane orthogonal to the direction you're looking at that follows you as you roll through a model. So with this enabled, this is what would happen. Say we have some object, and prior to any rolling, we can see just one side of it. And if we start rolling through, we'll get to a point where the eye or the perspective is inside the object, and the left half in the center graphic here is removed by Femap from view, so we can see the kind of the other side. And if we turned 180, that would be just like a simple rotation command in Femap, or using the 3D mouse, it's just a quick turnaround. The other half would be removed from view, and we'd be looking the other direction. So fundamentally, this is the process of how you can now use roll-through to peer into models in Femap, and I'll take you through another example here. Imagine trying to peer into a hollow structure, like say a fuselage with skin. Prior to 11.3, this required selective removal of entities from view, such as the left wall of the fuselage skin. You could have also set a clipping plane, but that was a more manual method than what roll-through is adding. So if you try to zoom, that's just going to make the part bigger in view, but we really haven't changed the eye location of this perspective that I'm showing here. With roll-through enabled, we can shift that eye location to be internal to the model. So we're traversing, what I like to call it, we're traversing through the model instead of just simply rotating and zooming in. So from here we can turn any which way and look at internal features from this new perspective, all because this command is stripping out the entities behind that eye that would normally be obscuring the viewpoint. This is quite a bit different than how you've been using Femap views before, so got a quick little demo here as well, roll through demo. It's a little fuselage, and I'm just going to zoom in on this with my 3D mouse. Once I get close enough, you see that it starts clipping everything behind that eye location. So I can see the internal features of this fuselage, which consists of some floor frames and stringers and windows and such. Just geometry here that I'm showing, but it demonstrates the point. Also in 11.3, pre-processing touch gestures are available. I don't have a, I haven't seen Femap used on a touch screen before, but I do know it's, actually I have seen it used on a Microsoft Surface Pro, so I can imagine this would assist with the usability on tablets as they become more popular. Connection Manager, this is new, it's got a better workflow. You can see they've added a filter and just a way to better manage and access all the connections at once for those who love to use connections and Femap, things like glue or contact. Here they've got an assembly of some rails and I guess a rack structure with a lot of, I believe, glued connections between the rails and then the vertical beams. I want to talk about element picking. There's a pick method that was available in 11.2 and maybe some versions before that. That was called Add Connected Elements. And this is great for kind of finding out what was connected, even if you had different visibility settings that prevented it from being obvious what was connected to the element that you had in front of you. So here I'm just showing that how an element is selected in the bottom left here, and then click Add Connected, and you get all the surrounding elements that share nodes with that. And that was really a segue into showing you a new pick method that's called Add All Connected Elements. So this takes it a step further. You select the seed element as before, and then use that pick method, and then Femap will run out there and try to find all the connected elements to that. And this is this could take a while if you have a very large model. If you've got a few million elements, this might take a couple minutes to run, so watch out for that. But it does have to go through the entire model and seek out all the connections and add what's connected to the dialog. But for smaller things, it makes it very easy to select everything that's connected in a hurry. Another selection item here is this fast pick visible. This is a new method for front picking. So previously, if you had, say, a circular structure like this cylinder here at the right, if you used the box select, Femap would select everything into the screen or depth of that model. That's kind of annoying when you may only want, say, the outer elements. So you can just select the outer elements now using a single pick, box, or circle, polygon, whatever. And that's enabled in preferences under this fast pick visible. I believe it's under graphics. And with that enabled, I can use the box as I would expect if I'm just selecting front by front method, and then click and drag a box, and now I've just got the elements in the very front there. So that's another convenience feature that they've added. Some streamlined element face picking exists in 11.3. This is going to demo here at the right the adjacent face functionality, which is the default face selection method now. Say we wanted to select all of the front elements on the block here to, say, apply a load or constraint. You could use the new fast pick visible option with the view correctly oriented as the last slide showed, or you can use this adjacent face option under face selection. Oops, jumped ahead there. Oh, it's not running. Oh, there it is. So here, I've just selected elements just by list, and I'll click method by face, and I have an opportunity to just select an element face there using face selection. With adjacent face enabled, I'm highlighting now all of the elements it picked up, and that's all the elements on that free face like I expected. All right, some beam modeling enhancements to talk about. You'll notice this cross-section definition window looks a bit different than before. When you're creating rod bar beam properties, this is what you should be familiar with, and is a little simpler in previous versions. But in 11.3 you have a couple of more options. And in the left smaller graphic you can see the what the user would see before any dimensions are entered. So it was a little difficult before because you didn't know what exactly you were adjusting. But with this graphic, it kind of orients you to what dimensions you are adjusting. And it will automatically add these guides at right here, so you can see the scale and the relative dimensions of things. It's sort of like a grid. And if you need to go back and reference what dimensions you're editing for, say, thickness of the bottom flange there, you can click on that button in red, and that will bring that graphic back up. So you can also see there's more feedback of the cross-section information, things like the dimensions. There's a little red dot there for the shear center, the centroid, and of course all of the properties listed at left that can be immediately calculated within the same dialog. Two changes to properties. On the left, this is a customer request to have unique property icons for different properties as just a visual aid. At the right, this is showing how the element creation dialog now limits the properties offered to you based on whether or not they'd be appropriate for that element. So if you're defining a beam element there and your property list looks like that, it's only going to offer you 1 through 5 there because those are of the bar element type. There's a new renumber all dialog, again offering more flexibility there. This is a request to be able to renumber all entities depending on the type. API program file libraries. We all know the custom tools that always sits up there that we can call our APIs from. That's always been available, but now we've got this user tools option. A lot of organizations will have their own corporate library of APIs, and this helps just point to those locations. It's a little cleaner than, say, adding a new folder under the custom tools option. Some miscellaneous pre-processing items. There's under the modify align dialog, there's a new option to align between 2 planes. For loads, there's a couple more options for boundary conditions, so loads and constraints there. Loads and constraints can have unique colors now. They don't have to be all the same color. That's adjusted by the F6 options menu. You can do things like modify the color scale or delete a bunch of selected boundary conditions all at once. So there's some better processing options there in Femap. Moving on to meshing. They made some improvements to meshing quads. So there's a new max quads meshing option that minimizes the number of triangles produced in the mesh to help you produce accurate quad dominant meshes. Femap has always preferred quads, as any analyst would, but now you'll notice a bigger reduction in triangle elements with this enabled. And at the right, this kind of demonstrates the on-off before and after of the default mesh having handful of triangles, and at the right it was able to reduce it to just one. Max quads can be combined with quad layers. Quad layers is a function that's always been around, an option that is. So quad layers, the purpose of those was to put cleaner quad elements around boundary features or just edges where a greater accuracy may be required. So it kind of forces quads to exist at the edge, and it pushes the necessary transition elements, which are of lower quality, to the acreage area where that may be more tolerable, say a little ways away from a stress concentration. But that in max quads is going to give you a lot of flexibility. This mesh growth factor was previously available for triangle elements. Now it's available for quads as well. And this factor is basically a ratio of the size of the elements between the size of the elements on the edge to what's on the inside, kind of between the boundaries. So for a low factor, you're not seeing much difference, and for a high factor, you can see that it grows in size in between the boundaries. And those are available. These are all available in a couple of spots when you're meshing a Femap. I like to use the meshing toolbox, and these are all listed right there under the mesh surface drop-down. So there is a new smoothing algorithm they're employing for highly curved surfaces. And when I saw this, I immediately thought of the sharp radius on a leading edge of a wing. So you'll see it's you know, a much better transition around that edge. Interactive mesh refine. This is kind of a real nifty feature that you can use to interactively refine an existing mesh, so where you may not have existing geometry. You can refine that in a specific region to, say, better capture a stress concentration, or for whatever purpose. It allows you to quickly refine the mesh of shell and also 1D elements, and it will critically automatically handle transitions and propagate any boundary conditions as needed. So it works really fast, and I particularly enjoy the speed of this one. You can drag over the number of elements, and it just refines it automatically very quickly. And I've got a little demo here where I'm trying to refine around this lug area. So let me restart that. So under Mesh Editing, Element Refine, you've got this new option. It brings up the dialog, and I'm just going to simply start selecting elements. Select there, and it's kind of giving me a preview of what it will result. So I could have very easily just dragged across and kind of done this immediately, but I wanted to see kind of what it was going to do and preview that. But you can see, just like that, it was super quick, and it refined that mesh. And if I had any boundary conditions there, it would have propagated those. Another fast mesh editing feature is this multiple element splitting. An edge split was added, I think, a few versions ago, but in 11.3 they extended this a bit by allowing multiple edge nodes to be selected. So instead of selecting just each pair of nodes to be split along individually, you can do more than one at once. So let's see what that looks like. So under Editing, Mesh Editing, Edge Split, I've got this box for multiple nodes, and I'm going to select the edge there, previewed that, the number of splits, the default looks okay. So I was able to refine that fairly quickly as well. So there's an update to hard points, and I guess they're calling it auto update now. So previously, if you put a hard point on a surface so that end up there while you were meshing, that kind of got lost if you did any certain geometry-based changes. If you made any of those, you might have lost that mesh point. So in 11.3, it's handled a bit better now. So you can create those, and they will stay even after you run any commands on the underlying geometry. So we had surfaces, now we got a mesh, and now say a change is made to the geometry, and it's remeshed. Those hard points will remain. Should remain on those underlying surfaces. Some geometry cleanup. In the past, they would create virtual curves and surfaces, also known as combined curves and boundary surfaces, as sort of like a last-ditch effort to clean up geometry. But now they've added even more fixes at the underlying Parasolid geometry engine level, where these things can be edited kind of permanently on the geometry itself instead of using, say, a combined curve to make sure that a hard point, like an edge point on a surface, doesn't create a mesh seed location. So that's under your meshing toolbox under feature removal. So there's you can see an additional option there for point and for curves for combining surfaces. Next, we're going to jump into some solver support items. All right, so there are a couple of things they added here. Additional translation notes can be found in the documentation if any of these have affected you before. I'm just going to do a quick rundown of these, and let us know if you need any more information on that. We can kind of send it your way, but it's pretty detailed stuff. The Nastran element quality, insofar as that's concerned, there are more checks available, and you can get to them pretty easily by the meshing toolbox under surface mesh quality. And before that item, we had a note about Abacus being able to attach ODB results. Previously in 11.2.2 and before, you had to internalize that data to the Femap database, and so your modfm might grow pretty large, but now you can take advantage of attaching to the database, which is the default behavior that I go with, and it works pretty well. But now it's available for Abacus solution results. All right, Nastran frequency response enhancements. They have read and write support now for all Nastran REQ entries. And there's a new solution frequency tab in Nastran dynamic analysis form. And that may be, no, I thought I had it here, but I don't. There is the ability now to create a non-zero constraint SVC in the constraint set. So normally if you're running force displacements, you can create some SPCDs, and those are related to a load set. But now you can kind of create them on the SPC as well. Grounded springs are now available. I believe this is a Nastran option for your connections, say grid A, grid B. If you left grid B blank, it internally grounded that, and you didn't have to specify a constraint on say creating a node for grid B and then constraining that, it would just automatically ground it. So that is now available. You can set that in Femap. There is support for configuring multiple solvers through this new dialog under Preferences, under Solvers. You can specify the path to your Nastran executable, Abacus, ANSYS, Dyna. All of the solution executables can be individually called out there and then specified. When you create your analysis set, you can kind of go between the different solvers. So that one analysis may point to an NX Nastran solver, and another might point to an Autodesk NEI Nastran solver, if you had those available to you. So this is the ANSYS solution setup dialog that's new. There's also an analysis monitor now in Femap for ANSYS solutions. And there's also the ability to create C-Bush-like spring elements. And you can also do this for Abacus solutions as well. They don't have, ANSYS and Abacus don't have a C-Bush-like element, but that can be replicated. And here, this graphic just serves to point that they're, in the underlying code in Femap, they are going to write out a contribution to your stiffness matrix based on the stiffnesses you put in for each degree of freedom there in the spring damper element type property definition window. So your stiffness contributions will go to your K matrix, and then your damping to your structural damping to your B damping matrix. All right, so Nastran results enhancement. So there are two new options you'll see under Preferences Results. One is use static subcase IDs. So with this option enabled, an attempt will be made to create output sets using IDs corresponding to the results for specific subcase IDs in a Nastran output file, which you've either imported or attached. If an output set with that ID already exists in the Femap model, then the next empty ID after that subcase ID will be used. So here we've got two runs, and you can see that the ID of the output set is 100, correlating to the subcase ID of 100. And then the next run, since it wasn't able to put it at an output set ID of 100, it put it at 101. So the other option is track revision. So that because this represents two runs, say the second is a revision of the first, you can see some codes appended to the end of the output set title. And with that option enabled, you'll notice a -C and a -R, which helps keep track of those runs that you made. So post-processing, they've totally rewritten the way that they're doing arrow plots as a contour view style now in Femap. And they're calling these by a different name now. They used to be called contour vector plots. They're now contour arrows. And they, just like any other contour, they take the color of the contour value for whatever entity, whatever element that they're applicable to. So they're much simpler to set up, and I'll take you through a few pointers on that. If you're looking at membrane forces, for example, it only requires you to select one of the components under output vector here, the second red circle there. And Femap will automatically determine the plot you want to look at, grabbing the associated Y forces and shear along with that, say, that plate X membrane force. And ditto for major and minor principal stresses, grab one and it will pull in the other. You can still isolate output by selectively disabling any vectors that you need there. It gives you the option still to do so. And transformations are now much easier to set up with these contour arrow plots, and they can be calculated and displayed on the fly using that listed option there under transform in the post-processing toolbox there. Lots of styling options to fit user preferences. Major and minor principal stress, plate membrane forces, beam force arrow plots. They're all easy and fast to set up and create. Here's the default arrow types for each of those. Contour arrows can also be used to display displacements. The options for C-bush elements are shown in kind of two ways here. You can either have the components visible, or if you know the two directions for shear, you can have it display that resultant as well. And all of this data, of course, they've set it up so it can be added to the data table quickly to be sorted or brought out to Excel. All right, let's move on to free bodies. For those, they've added in support for glue and contact contributions to the free body calculation. You can see right there. Now when you, let me go back. Now when you are showing free body summations, you'll actually be able to see an equilibrium balance there because they've added that option in. All right, now the free body listing under list output, force balance. Those have been cleaned up, kind of condensed into a new menu for force balance, and it brings up this dialog at the right. So all those options have been consolidated into a single dialog box, and interface loads can be sent directly to the data table, and it's very easy to go from there to Excel. This is how the interface loads will appear in the data table if you push them to that on the left there. Then at the right, this is how it looks coming off the clipboard into Excel. So it's very similar in the format of the FO6 file if you requested the grid point force balance data to go to your FO6 file. Okay, so you can now set defaults for free bodies. If you found yourself repeatedly configuring your free body settings for your own preference each time you created one, well, now you can do that just once under preferences, and it will save that for all future free bodies that you create. New support for charting based on analysis studies. That means you can more quickly plot output without going through every standard chart and data series creation step. You can just right-click there on the analysis study, dig down to plot study, and they offer a couple different options there. Lastly, just want to touch on some performance changes. As is usually the case when you stumble upon an inefficiency in Femap and it bothers you, by all means send that in. Let us know. We can pass that on to the developers, and they'll try to address that and see what inefficiencies may exist in their underlying algorithms. And just such a thing happened for this Nastran XDB attach. They rewrote the way that they bring in composite element results. That's 60 times faster now. Some fundamental, a very fundamental aspect of the API in Femap is dealing with sets, which are just essentially lists of things like element sets. And they improve the way that they are accessed and used internally, so they're much faster for adding and removing IDs. Jumping down to performance graphics. Performance graphics is very matured now and has been an ongoing improvement across various versions of Femap as they move and try to get more things rendered by your graphics card directly. And that just improves the speed of things like dynamic rotation and model regeneration within the graphics window. So there are some changes there that have occurred. And that pretty much wraps it up. We'll take any questions now, but I have to say my personal favorite. My top 3 changes for 11.3 are probably that draw erase menu that replaces some custom APIs that we wrote in-house to do some similar things, but not as much, and this is much more simpler and elegant. Dynamic rotation about cursor, that's going to prevent a lot of fidgeting with setting a rotation point each time you kind of move around the model. And also the quad meshing improvements are great to see. Geometry cleanup, dynamic mesh refinement, max quads, they'll all make great improvements to 2D meshing. So with that, if we have any questions, we can take those. I'll leave a few moments here for you to submit any questions. But if you don't have any, feel free to drop off, and we'll let you know when these slides become available.
And Eric, you were asked one question during your presentation. Can the screenshot, a picture copy-paste, be saved in the roll-through graphics window for use within an analysis report?
I have not tested that, but I imagine you can.
Yeah, I actually tested it. In fact, I think you did it to make the picture for your presentation.
That could have been just a print screen in Windows. I wasn't sure. But yeah.
Yeah, I did check. Control-C will copy that picture just like it's on the screen.
Yep. When they render images, that's good to hear. I expected as much, since each kind of view in the graphics window there is a rendering. Your model is actively rendered, so it should be very easily to pull out that rendering and save it through your standard Control-C or File, Save Picture operations. All right, I want to thank everyone for watching, and if you have any questions about 11.3 or Femap or our symposium, feel free to reach out to us, and we'll get back to you. All right, thanks everyone for watching.